Okay, greetings, aspiring scientists. Welcome to today's video. So I have decided that after I work really hard and make about 5 videos about real lesson topics, I'm going to do some guilty pleasures and make some top 10 videos or just have some fun and not worry too much about preparing or really conveying in-depth information. So hopefully you'll stick around and just enjoy today's video, which is the top 10 most difficult standard level IB chemistry units, in my opinion. So I'm going to try and cut the units down to as concise as they can be, which is usually a number, point, a number, point, another number. That's like as specific as the units get, and I'm not going to include HL videos in this because it would just be full of HL, and then the SL people would not really have much to think about or talk about on this topic because they haven't studied those topics. But perhaps I'll make one in the future about HL only or combined SL-HL. Anyway, starting with number 10. I think one of the most difficult units is reactivity 3.4.2, that's nucleophilic substitution. Now, I'll admit that the SL version of this is the HL version is much more complicated. But even in SL, this is kind of one of the first times when you have to think about how something happens via specific movements of electrons and nuclei and things like that. Before that, you've kind of just been looking at, what do we start with and what do we finish with, balanced chemical equations. But you also have to consider, what's a good nucleophile, what's a good leaving group, where does it attack? Where do you draw the arrows? What's a concerted mechanism? These kind of things. And even stereospecificity. I don't know that you need to know all those things in SL, but they are good to know, and you realize how complicated the process can be. Anyway, next, number 9. I would say structure 1.4.5, concentration. And I think the basic idea of concentration is not that difficult. C equals N over V. Concentration equals number of moles over volume. But it's going beyond that where things get really difficult, where you start mixing multiple solutions, where you start having to do serial dilutions. Like sometimes practice questions or exam questions say, how would you make 5 solutions to calibrate this instrument, this UV-Vis spectrometer or something? And most of the time, my students just completely blank. They don't know where to begin, and I have to tell them, just explain what you would actually do after you step into the laboratory or whatever. But it's difficult to answer if you've never done that, so I really recommend you do some practical work where you do serial dilutions. And also, there's titration questions in there where you have to mix stoichiometry and balancing chemical equations with concentrations and volumes. That can get quite difficult, even for SL. Next, structure 2.2.6, I would say, is number 8 on my list, and that's molecular polarity. I think most people get the idea of bond polarity, but when you start thinking about 3D structures, especially people who haven't taken physics and don't really know what a vector is, are not good at figuring out when vector addition of all bonds equals to 0 and when something is nonpolar. And to be honest, the larger that molecules get and the more bonds they have and the more spread out the position of lone pairs and electronegative elements becomes, the more and more difficult this becomes. And it's really not even possible for high school students to really do large molecules. And so I think that can confuse some students when they try to do so. But yeah, I would just really go learn what vectors are before you even try this unit. Okay, next, number 7, I would say reactivity 2.2.1. This is the absolute beginning of rates. And SL rates, overall, I think are quite difficult, but later on, it's actually not as difficult when you actually consider collision theory and what affects rates. I think that's actually pretty understandable and explainable. But it's the beginning of rates where you learn about the equations and the effects of coefficients and the fact that there can be single reactant rates and whole reactant rates, and they're not the same usually. That really confuses students, and I think it requires reading the chapter of a book that has that multiple times, or reading online resources and things and really doing practice questions until you understand it. All right, next I would say number 6 is 2.2.9 from structure. That's intermolecular force comparisons. So I think the intermolecular forces, students do actually learn them quite well, quite quickly, although London forces, the idea behind it takes students the most time. But it's after you learn them all and you start seeing molecules that have all of them mixed together, different amounts of electrons and London forces and polarity and possibly hydrogen bonding, and then you're asked to compare such molecules, it's very difficult to prioritize what generates the most or the strongest forces, because it could be London forces if there's a lot of electrons or molecular weight. It could be hydrogen bonding if there's 1 or 2 or 3 spots for it. Could be polarity, could be the shape of the molecule. Linear ones are different from compacted or T-shaped ones. And looking at larger molecules, I've seen in textbooks and practice questions, it's not clear which of those things you are supposed to prioritize. And honestly, you probably just need to go to the lab and figure out, for that particular compound, what is its boiling point and why is that? You can't really do it just by looking at structures on a page. Anyway, number 5, I would say, is reactivity 3.2.2. That's half equations. So I think the basic idea of this, that you can split a redox reaction into 2 halves in terms of electrons gained or lost, is not that difficult. But it's when you start getting into the complicated acidic aqueous solution redox reactions where there's multiple steps and you have to add unlimited amounts of H plus or H2O to whatever side needs it to balance the equation, that these get very difficult and beyond most SL students' skills at the time when they study this. So it's not that common, especially with the curriculum update, that you get difficult questions on this, I think, but still it's possible, and I think it's really difficult. Next, I would say number 4 is 1.2.2 in reactivity. That's Hess's law. And I'll agree that this is, again, much more in-depth in HL. But in SL, you still need to be able to add together equations. And I think that's the first time you really come across the idea that you can add equations, cancel things out. And, especially the things called triangle diagrams, where you have like an equation and then several compounds underneath connected by arrows to show that both paths are energetically equivalent. I think those are very hard to interpret and draw sometimes, especially because you have to get the direction of the arrow right, the sign of the energy correctly. And honestly, I make mistakes in it all the time, and I prefer to actually just draw a huge Born-Haber diagram from HL, where everything is set at a specific energy level on a scale on the left side, and I'm not just sort of guessing by drawing arrows of different directions and lengths. Anyway, not my favorite unit, but certainly possible to learn. Then next, I would say number 3 is structure, 3.2.5. This is organic nomenclature. Organic chemistry is my favorite and my specialty, but I do recognize how many bases and suffixes and prefixes you just have to remember, especially if you're not a native English speaker and you don't know much Latin prefixes and suffixes. It's just a huge amount of stuff to learn. And I would also group in just what the functional groups are in the difficulty of this unit, because you have to know those as well. So very difficult, but one of my favorites. Number 2 then, I would say, is structure 2.4.2. This is the bonding triangle, a diagram that's probably in your textbook and data book that has differences between metallic, ionic, and covalent bonding, and you're supposed to judge the properties of a compound based on where the bonds fall in that triangle. But trying to compare things on a 3-point scale is very difficult. It's very difficult to say whether it's going to actually conduct electricity or have strong physical properties or, be more metallic or covalent or ionic, because there's no set boundaries on when those things happen. You kind of just have to look at what's around it and what you know from previous knowledge. Very difficult, I think. And then, number 1, I think I would say, is drumroll please, reactivity 2.1.3, limiting reagents. And part of this is just that you absolutely must know it and master it because it appears on nearly every exam that I've ever seen. And yeah, the idea that one of the reactants will be used up first in a chemical reaction between multiple reactants, and then that one defines how much products will be made, how much target product, how much side product, and how much other reactant will be remaining, how much of the excess reactant will be remaining. The possibilities of what you could be asked about this are huge, and then depending on the balanced chemical equation, the ratios you might have to deal with are also possibly very difficult. You might deal with like 6 over 7 or 12 over 8 or various different fractions and ratios that you need to know how to apply to the limiting reactant amount of moles to generate all your answers. It's very difficult. It's something that most of my students really struggle with. But it can be overcome with enough practice. So that's my list for today. Hopefully you enjoyed. If you agree or disagree, let me know in the comments. And again, I'll get back to making serious lessons for my next few videos. If you haven't seen them yet, please check them out. They're, I think, quite good explanations of IB chemistry topics. All right, that's all for today. See you later.